Hi there. In this video, we'll talk about high watermark. So basically, what is high watermark? High watermark is nothing but the top block till where the data has been inserted into a table space, into a segment that is assigned to a table. So that's called as top watermark. So why do we need to know about the top watermark? I mean, high watermark and what is the top block where the data has been inserted and all, right? And so if you look at this is how the table space and the storage looks like when we insert the data into a database. So the first thing what we have is like table space. If you look at my very first video where I mentioned about different database layers that are involved within the database, table space is one of the options which is always associated to a table. I mean, like each and every table should be associated to at least one table space. And within the table space, we have something called as segments, and a segment can have multiple extents. So a table can have one or more segments. Usually, like until unless you have any club columns or blob columns, you'll be having only one segment, and each segment can have multiple extents, and each extent can have multiple blocks. So in this case, I have one segment that is associated table. Imagine, and the segment has three different segments, and so three extents. Each extent has number of blocks, as we can see here. And imagine that anywhere you see the block that is filled with black color, that means like it is currently holding the data. Anywhere you see the block is having white space, that means that like it doesn't have the data, right? So imagine that like you have inserted the data into a table which is used by this particular segment, and you have inserted the data till here. That means that you have three extents, and the data was inserted till here, right? Because this is the top element where the data was inserted. So all of this space now used by the table, right? But how many, however, if you look at it here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 blocks that are really empty. So why this could have happened? Why there are 10 blocks which are empty? This is because probably like the data was deleted from the table, and when the data was deleted, whatever the blocks where the data was existing, all of those blocks data was deleted. However, when the data was deleted, automatically these blocks will not released back into the memory so that someone else can really make use of this space. Instead, it still gets hold, and that's where we call it as high water mark. So imagine that like someone is trying scan the table, and when the scan, the database doesn't really know that how many of the blocks are holding the data. Instead, it will look at how many extents are associated to the table, and it will search for the data across all those extents, across all those blocks, irrespective of whether the block has the data or not. That means you trying to scan all these blocks which are empty still, because database doesn't know it, right? So when you delete the data and you don't gather the statistics, and you try to select the data from the table, if it in case if the operation is going to do the full table scan, then in such kind of cases it is going to scan through all these empty blocks and leads to the performance issues, right? And in case if you truncate the table, what happens is it will release, I mean it will clear all these blocks till the top element which is being used by the database. However, while truncating the table, there are two options for us. One is reuse the blocks, I mean reuse storage or drop storage. So what it means is that when we truncate the table, basically whatever the blocks that we have till the top element, all those blocks will be emptied, any data that resides in those blocks. And if we reuse the space, it doesn't really release the memory back into, instead it will be reused when we try to insert the data again into the table. However, in case if we say that drop storage, that means like it is going released back into the memory, into the pool. That means that some other table can really make use of those blocks to insert the data. So imagine that like you are going to drop 1 million rows, and then you are going to reinsert 1 million rows once again into the table. In such kind of cases, maybe specify the option like space while truncating. If it is delete, obviously we don't have this option, it will just delete the data from the blocks, right? So this is one of the difference between, in fact, like delete versus truncate. If someone is deleting the data, it will leave the high water mark. That means that database will still assume that all the blocks that are associated to the table will be having the data, and which means that like whenever we do the full table scan, it is going to lead to the performance issues. In case if we do the truncate, it is going to wipe out all the memory from all those blocks, and then based on the option what we specify, whether the memory will be released block into the pool or it can be still hold by the table, so that we can reuse when we insert the data, right? So I'm going to specify all these commands, and how to specify, like whether we can release the memory or whether we can reuse the memory when we truncate the table, and what exactly uh, delete operation comes under DML, and truncate comes under DDL operation and all. But this is one of the major reason. Truncate comes under DDL operation because when we truncate it, it is going to wipe blocks data, and this is nothing but like dealing with the structure, and that's why we call it as DDL operation. Whereas DML is like deleting the data row by row. We'll talk more about it during DML operation. Till then, take care. Have a good day. Bye bye.